G'day everyone, in this video we're actually going to be looking at finding the gradient at a particular point on the graph. So that's what we're actually going to be looking at, and that's the point of deriving functions, because deriving a function is actually the function of the gradient. So that's what we're actually going to be doing. So when we have f negative or f dash 1, all that is saying is what is the gradient of fx when x is equal to 1. So that's what that actually is saying. So f dash 1, that's what you actually need to find out. You're finding what the gradient is of fx when x is equal to 1. So just remember that, and we'll get into these questions here. So for the following, find f dash 1. So first we need to differentiate these functions, and I'll do the first one and then the second one in completion. So we differentiate this first one, so fx. So this we're just using, and you can see it already highlighted up there, that first rule there. So this becomes 4 times 5 x to the power, and we drop this down by 1, which is 4, which becomes 20 x to the power of 4. So that's f dash x. Now we're just finding what the gradient is when x is equal to 1. So we substitute 1 in for x. So this becomes 20 times 1 to the power of 4, which is equal to 20. So that's what the gradient is when x is equal to 1 of fx there. So we're going to do the exact same thing for the second one here. Even though it's got some minuses in here, you can see when you're using the difference, so when you've got functions or variables within that, you can actually just differentiate them separately and just minus them at the end if they're like terms, or just leave them as it is. So we're going to be doing this. So we're going to find f dash x first. And this actually just works the same. So it becomes negative 10 times 3x, and we drop that down by a power to make it 2, minus 2 times 2x, and because it doesn't have a power, it's the power of 1, so we don't need to write it. And 2, just remember this is a constant, so its derivative is equal to 0, so we don't actually need to write that. Okay, I'm just going to put a plus 0 on the end just to show you that it is there, but it is 0. So we just need to simplify these. So we've got negative 30 x squared minus 4x. And these aren't like terms, so we leave it like that, and that's what f dash x is. And we do exactly what we did before. We're finding the gradient when x is equal to 1, okay, by substituting 1 into our gradient function. So we got f1, and this is equal to negative 30 times 1 squared minus 4 times 1. So it becomes essentially negative 30 times 1 minus 4 times 1. So it's negative 30 minus 4, which is equal to negative 34. So that's how we actually work these out. So just remember what this notation means, okay? So, but all it's saying is you're substituting 1 into your gradient function. So after you derive it, substitute x for 1, and that will give you the answer. So hopefully this helps, and good luck.